Exercise 15C, Precedence Tables and Activity Networks. A network can be used to organize a schedule. There are two rules for activity or project networks in order for it to be used as a schedule. One, if you've got one activity, it can't proceed until the ones immediately before it have been done. And secondly, that you can't have parallel edges. You can't have two activities being completed at the same time in the same way. And we'll get to what we mean by that very shortly. So example 1, below is an activity or project network. On the right is a precedence table. Explain what the column headed predecessor means using examples from the table. So let's have a look at what this table is saying. So we have an A, we've got a B, and it has two dashes there. So let's have a look here. So we can see A, B, two dashes. And then if I look at C and E, so C and E, they've only got the letters A next to them. And if I look at F and H, there's F and H, F has A before it, and F has B and E before it. So let's have a look at F and H to start with. So what does a predecessor mean? So pre meaning before. So for instance, if you're invited to a pre-screening of a film, you are watching it before it's being released. So a predecessor is any of the edges or activities that are represented in the edges that came before that particular one. So for example, H has listed A and F has listed B and E. Interestingly though, we've got B and E, but it hasn't mentioned A, and A comes before it too. So therefore, our definition of a predecessor are the edges that come immediately before that activity. So if there aren't any predecessors, then we just have to write a dash, as we have done with A and B, as there are no edges before it because they are connected to the starting vertex. Write the precedence table for the following network. So what we need to do is we need to go and write what comes before each of these. So for A, there are no predecessors before A, so that's a dash. For B, there are no predecessors before B, so that's a dash. C, the only predecessor that comes before A, if we have a look. So when I say predecessor, I mean the one that is pointing towards the direction of that. So some people get confused and say, well, why isn't D a predecessor? That looks like it's before C, but no, it's pointing away from C. We're looking at all of the edges that are pointing immediately into that one. So A is pointing into the direction of C. So therefore, that will be a predecessor. For D, the only predecessor for D is A. For E, now the E has two predecessors pointing into E. So in this case, it will be B and C. It doesn't matter if you haven't got them in alphabetical order, but it always looks nicer if you have. F, the immediate predecessors are the same as E, B, and C. For G, the immediate predecessors will be D and E. For H, the immediate predecessors are also D and E. For I, the immediate predecessors for I will simply be H. For J, the immediate predecessors will be F and G. For K, the immediate predecessors will be F and G. For L, the immediate predecessors will be I and J, because they're pointing into L. And M, the immediate predecessor for M is H. So one of the skills you need to be able to do is to translate an activity network into a precedence table. Or usually what happens in an exam is that you may have one of those blanked out and you'll need to go and fill in what is missing. One of the other skills you need to be able to do is to draw a possible activity network or identify an activity network based on its precedence table. So example 3, draw an activity network that would generate the precedence table on the right. Now I'm going to draw one version of what it might look like. However, please know that these sorts of graphs can be isomorphic. So what that means is that we can draw various different versions of it. The only thing we try to make sure that we do is that there are no dangling edges. So we try to make sure that it has a definite start and a definite end. If somehow there's a dangling edge, we try to go and connect that to the end. So we've got A and B have no immediate predecessors. So I'm going to start by drawing those. Activity C, the immediate predecessor is A. For D, the immediate predecessor is A. For E, the immediate predecessor is B. For F, the immediate predecessor is C. G, the immediate predecessors are D and E, which means we might need to just redraw this slightly so they can connect into each other into G. And lastly, H is predecessors are F and G, so we may need to just redraw F and G slightly and connect H accordingly. And thus we have drawn our activity network.